The digital meters directly displays the signal and displays the quantity in terms of deflection of the pointer. Actually, analog instruments, deflection of pointer indicates the measurand. That is analog displacement angle corresponding to electrical quantity. The pointer indicates the measurand in case of analog instrument, but in digital instrument directly the value will be decimal number, or digital meter works on the principle of quantization. Directly it will display the signal in the form of decimal number or digital number. The digital meter works on the principle of quantization. That is the main principle of digital meter. Nowadays if you go for wherever you go for nowadays metering or instrumentation, totally we are not using analog type. If you go for, already I told you, if you go for ECG also one type of digital, or if you go for pulse, digital pulse oximeter, it is a pulse totally, not analog meters. Analog meters does not work because of some lot of disadvantages are there for analog instruments, but in laboratory purpose we are using digital meters. We can easily store the digital data in case of digital instrument by like memory cards. If you take memory cards, we have digital oscilloscope. In digital oscilloscope also we can store the data, whatever the signal obtained on oscilloscope, whatever be the signal obtained in oscilloscope, that can be stored in a memory. By using pen drive we can take the printout also in digital meters. Digital oscilloscope, if you consider digital meter, it is also one type of digital meter. Nowadays we are using multimeter. In olden days multimeter will be like this, a pointer will be there, multimeter. If you want to measure the resistance, multimeter, a pointer will move. This is also analog multimeter. Now it is digital multimeter, directly shows the values in terms of digits. Digital multimeter, you are working with laboratory. Digital multimeter, you measure the resistance also. The digital meters plays key role nowadays because it is very easy to construct, easy to measure, and easy to observe the quantity without any error. Because the what is the error is parallax error will be reduced. There is no moving parts, hence it is friction errors also reduces. Frictional errors, those are also reducing. Okay, that is the advantage of digital instrument. First of all, we know that what is resolution. Resolution in digital meters. What is resolution in digital meters? What is the resolution? The number of digits displays the signal, that is called resolution. For n digit display, somebody entering. The resolution in case of digital meters plays key role. That's why we are referring digital meters, because of resolution is more as compared to analog instruments. The digital meter, the number of digits used for a digital meter decides its resolution. The resolution, number of digit positions, the number of digit positions or number of digits used in a digital meter determines its resolution. A 3-digit display, for n number of digits, the resolution is given by 1 by 10 power n. 1 by 10 power n is the resolution. That formula you have to remember. But for in case of analog instrument, the minimum quantity able to detect by the meter is known as resolution in case of digital meters. A 3-digit display on digital meter for 0 to 1 volt range will be able to indicate values from 0 to 99 millivolts. 999 millivolts, the resolution is 1 millivolt, or smallest increment is 1 millivolt. If n number of digits are there, then resolution is given by 1 by 10 power n. For a 4-digit display, the 1 by 10 power 4 is 0.0001. That is 0.01% is the resolution. The sensitivity also more in case of digital meters. The principle of digital meter is quantization. What is meant by quantization is the analog quantity measured, first it is subdivided into number of quantas. Each subdivision is known as quanta. The analog quantity to be measured is first subdivided into or quantized into number of small intervals. The number of small intervals may be each decimal places. Number of small intervals, we are dividing. where it is pen, we are using pen. Okay, the analog quantity to be measured is first subdivided or quantized into number of small intervals up to many decimal places. Okay, that is the important thing. In the objective of digital instrument is that it is then determined which portion of the subdivision is measured. That can be identified by integral multiples smallest unit called quantum. Which portion is to be measured chosen for subdivision, that is known as quantum. The objective of the digital instrument is identify which portion has to be measured. సబ్డివిజన్ చేసి ఉంటాం ఒక సిగ్నల్, అనలాగ్ సిగ్నల్ని ఫస్ట్ డిజిటల్గా కన్వర్ట్ చేస్తాం. అక్కడ నుంచి మనం ఏ పోర్షన్ మెజర్ చేయాలనుకున్నామో ఆ మీటర్ సెలెక్ట్ చేసుకుంటుంది. ఈచ్ పోర్షన్ స్మాలెస్ట్ పోర్షన్ ఈజ్ కాల్డ్ యాజ్ క్వాంటమ్, దట్ చూజన్ ఫర్ సబ్ డివిజన్. అంటే అనలాగ్ని డిజిటల్గా కన్వర్ట్ చేసి డిస్ప్లే చూపిస్తుంది. ఆ అనలాగ్ టు డిజిటల్ కన్వర్షన్ టెక్నిక్స్, సో మెనీ టెక్నిక్స్ ఆర్ దేర్. వన్ ఆఫ్ ద టెక్నిక్ ఈజ్ క్వాంటైజేషన్ అండ్ అనదర్ వన్ ఈజ్ quantization and sampling. Another one is sampling. Sampling is the another process that is used to convert analog signal into digital signal. Procedure in digital meter is, the measuring procedure of this digital meter is to reduce the number of quantity to one count. That is the measuring procedure thus reduces into one of counting the number of quanta present in the measurand. అంటే ఎన్ని మెజరెండ్ మనం సబ్డివైడ్ చేసి ఉంటాం కదా, అవి మెజర్ చేయడమే డిజిటల్ మీటర్ యొక్క మెయిన్ వర్క్. ద అక్యురసీ కెన్ బి ఇంక్రీజ్డ్ టు డిజిటల్ ఇన్స్ట్రుమెంట్ బై ఇంక్రీజింగ్ ద క్వాంటైజింగ్ లెవెల్స్. నెంబర్ ఆఫ్ శాంప్లింగ్ రేట్, ఇఫ్ యూ ఇంక్రీజ్ ద శాంప్లింగ్ రేట్, నెంబర్ ఆఫ్ శాంపిల్స్ పర్ సెకండ్, దట్ ఈస్ నోన్ as శాంప్లింగ్ రేట్. Here analog signal will be converted into number of samples. After that is counted by meter, that displays in terms of volts, in terms of resistance, like that. The accuracy can be increased by increasing the number of quantizing levels. Quantum levels, if you increase, the digital meter accuracy can be increased. As usually, what are the advantages of digital instruments are? Greater speed, increased accuracy, better resolution, and less errors. I already told you. Simply direct reading, it is easy to store. We can store the data and we can easily send the data to somewhere, because through online also it is possible. Through cables also we can send the data. But analog instruments, though through cables we can't read. The human has to come after that. He has to take the reading and entering into digital. That is possible only in analog instrument. But in case of digital, directly we can send that to somewhere, because it is possible by using mapping also. How the Google map is totally, it is digitalized, hence only mapping is possible. Easy to store. Those are some advantages. Everybody knows the advantages of digital instruments. Next, what is the resolution? Resolution is the one of the formula is 1 by 10 power n. For n number of digits, resolution is like that. Sensitivity also more. Sensitivity is given by one of the formula. Sensitivity means, already I told you in static characteristics, sensitivity is the smallest change in input for which the digital meter able to detect. Sensitivity and resolution. The sensitivity, smallest voltage range of full scale value measured by meters resolution. Sensitivity, one formula akkada chudandi. One of the formula for sensitivity is, sensitivity is given by full scale deflection into resolution gives sensitivity of digital instrument. Full scale minimum value, suppose the scale of the instrument is like that. Digital instrument, digital meters lo aithe mana 0 to 20 milliamps అని ఉంటుంది. Full scale reading is 20 milliamps. 0 is the minimum. 0 into full scale minimum reading is 0. 0 into resolution, if you multiply, then sensitivity of the meter will come. This formula is important. Digital meters, how to calculate sensitivity. What is the resolution of a 3.5? Here we have to, number of full digits we have to assume to calculate resolution. Half digit display, 3.5 digit display, half digit will not be considered. Half digit, full digit, number of full digits are 3. Therefore 3.5 digit display resolution is 1 by 10 cube, that is equal to 0.001 or 0.1% is the resolution. Full scale range is given by, assume that full scale range is 1 volt, resolution on 1 volt range is 1 into 0.0001 is 0.001 volt. Hence 1 volt range will not be able to distinguish between, ఇది ఒక numerical problem. Actually problem is, now we go for digital meters, digital voltmeter, DVM. A digital voltmeter displays the value of AC or DC, because in case of moving iron, moving coil, like that instruments are there, but digital meters can be used for both AC and DC, that can represent any value AC or DC voltage being measured directly in discrete numericals. In terms of numbers directly it will display in the decimal number system. It displays the all the signals, whatever the voltage we given to digital voltmeter, it displays. It eliminates the observational error committed by operators. Already you know that a parallax error will be reduced due to digital voltmeter. The errors on account of parallax and approximations are entirely eliminated due to digital voltmeter. The use of digital voltmeter increases the speed with which readings can be taken. The readings can easily taken with fast accuracy, and number of digits we can take easily. That is the advantage of digital voltmeter. Now we go for types of DVMs. What are the DVM means? Digital voltmeter. There are various types of DVMs. Generally they are ramp type, integrating type, potentiometer type, successive approximation type, continuous balance beam type. That is DVM continuous balance type. It is very interesting to know what is the DVM, how it works. Ramp type DVM, integral DVM. First, quantization is the process. The number of quantas will be in all types of DVMs. The number of levels, quantization levels, how many, suppose the signal is divided into number of sub levels. Suppose the signal is divided into number of sub levels. Suppose the signal is whatever be the voltage, that is divided into sub level, number of quantums. Each level is known as one quanta. Now the digital meter counts the number of quanta, number of sub level samples that will display. All meters based on working this principle only. And another type is there, ramp type DVM. In ramp type also, one of the signal, ramp signal will come and counts number of quanta levels. The number of quanta levels count, after that it will display the signal. It will display the value of voltage. What is that? In ramp type DVM. In ramp wave we were using, hence it is called as ramp type DVM. Okay, now let us discuss first ramp type, after that integral type DVM, or that is also known as integrating type DVM. Integral type or integrating type, it is also known as integral type or integrating type. Another one is potentiometer type digital voltmeter. Successive approximation method we are using, hence it is known as successive approximation type DVM. Continuous balance beam type. In this the important thing is, these two are very important, ramp type and integrating type. These are the some of the methods. Successive approximation method, it is very simple, but these two are very important according to instrumentation subject for students. In every digital voltmeter or digital meters, the basic function is that preferred is analog to digital conversion, ADC, that is analog to digital conversion. After that, number of counts it will be counted. That is characteristics of DVM. Sometimes it is interesting to know that digital meter will be connected in wires, or in a circuit we are connecting digital meters. What are the characteristics required? If you know the op amp, operational amplifier, what are the characteristics are required for op amp? It a high input impedance, like that. For a digital voltmeter also, if you connect in any circuit, the circuit should not take excessive current. The circuit should not take huge current. It should not alter the conditions of the circuit. That is the characteristics of DVM. Absolutely, it has a high input impedance. High input impedance should be high because of operational amplifier. If you consider, for that also high input impedance, low output impedance it is. Similarly, characteristics of DVM is input range from 1 volt to 1000 volts with automatic range selection and overload indication also. The characteristics are high. The accuracy will be always high, 0. plus or minus 0.05. A digital meter have typically 10 mega ohm high input impedance. It is not only resistance, it has high input resistance, high input impedance also, and input capacitance of 40 picofarad. Internal calibration from stabilized reference source. It digital multimeter, if you consider, it will internally calibrate according to the మనం రేంజ్ చూసుకోవాలి. ఒక మీటర్ కావాలి 10 amps అంటే 0 to 10 amps అమ్మీటరే పెట్టాలి. బట్ ఆ అమ్మీటర్ డిజిటల్ అమ్మీటర్ ఆటోమేటిక్లీ ఇట్ విల్ క్యాలిబ్రేట్. Automatically it will calibrate, that is stabilized reference source తీసుకునేసి automatic calibrators. Characteristics of DVM: input range from plus 101 volt to 1000 volts with automatic range selection and overload indication also there. Absolute accuracy is very high, that is plus or minus 0.005% of the reading. Accuracy will be more. The resolution is 1 part in 1 million. 1 part in million, that is 1 microvolt reading can be measured on 1 voltage range. 1 microvolts. It is impossible to measure by using analog instrument 1 microvolt. On 1 volt range it can easily measure. Input resistance typically 10 mega ohm. That means high input impedance will be there for digital voltmeters. Internal calibration with stabilized reference source, that is. Let us go for ramp type digital voltmeter, ramp DVM. Ramp type digital voltmeter. What is the principle of operation of ramp type DVM is, the operating principle of a ramp type digital voltmeter is to measure the time of linear ramp. What is the linear ramp? You know that linear ramp. It is a ramp voltage, ramp signal, or it is also ramp signal. It is also ramp signal. Here we are using negative ramp. In ramp type voltmeter, if it is a positive ramp means it is the positive ramp. If voltage is increasing with respect to time, it is a positive ramp. The voltage will decrease with respect to time, it is a negative ramp. Okay, here we are using negative ramp. The operating principle of ramp type DVM is to measure the time of linear ramp. Voltage takes change from level of input voltage, that is 0 voltage to 0 voltage level to input voltage. That is the operating principle of a ramp type digital voltmeter is to measure the time of linear ramp. Voltage takes to change from level of input voltage to 0 voltage. That means suppose ఒక voltage 10 volts ఉందనుకోండి. Suppose a voltage is 10 volts. ఫస్ట్ ఈ ర్యాంప్ ఏం చేస్తుందంటే 10 voltsని టచ్ అవుతుంది, మ్యాక్సిమం పీక్ వోల్టేజ్ని. ఆ ర్యాంప్ కంటిన్యూ అవుతుంది 0 voltage వచ్చేంత వరకు. ఇది అక్కడ నెంబర్ ఆఫ్ సబ్ డివిజన్స్ క్వాంటాస్ క్రియేట్ చేస్తుంది. అంటే ఫస్ట్ ఒక 10 volts ఇలా ఉంది, 10 volts ఇలా ఉంది అనుకోండి, సైన్సాయిడల్ సిగ్నల్. ఏ ర్యాంప్ వోల్టేజ్ విల్ బి టచెస్ ద పీక్ వాల్యూ, ఆఫ్టర్ దట్ ఇట్ రీచ్ టు 0. అక్కడ మధ్యలో నెంబర్ ఆఫ్ లెవెల్స్ మెజర్ చేసి ఇది ర్యాంప్ టైప్ వోల్ట్మీటర్ వర్క్ అవుతుంది అన్నమాట. The operating principle is, first the linear ramp touches the highest point, after that 0 voltage and 0 voltage level of input voltage. During this interval is measured electronic time interval counter. ఒక కౌంటర్తో నెంబర్ ఆఫ్ పల్సెస్ ఎన్ని జనరేట్ చేస్తుందో ఆ నెంబర్ ఆఫ్ కౌంట్స్ డిజిట్స్ ఈజ్ నోన్ యాజ్ వోల్ట్మీటర్, అవుట్పుట్ ఆఫ్ ద వోల్ట్మీటర్. అంటే లీనియర్ ర్యాంప్ టచెస్, యూ కెన్ సీ ద డయాగ్రమ్ ఆల్సో. The ramp type DVM consists of one ramp generator, and ramp voltage should be generated. After that, attenuator, input comparator, ground comparator, and clock oscillator and counter. Ramp generator generates the voltage, attenuator attenuates the what is the signal, input comparator and ground comparator. Input comparator means peak value will compared, ground 0 reach, when it reached to 0, then ground comparator compares, clock oscillator and counter. These are the various parts. Let us see the diagram. Let us see the diagram of ramp type voltmeter. Ranging and attenuator, whatever be the input voltage, that should be altered according to the meter. According to the meter, that is attenuator attenuates the unwanted signals. After that, it reduces the voltage level. Input comparator and ground comparator, two comparators are we are using. What is comparator? You know, two comparators we are using, input comparator and ground comparator. Okay, the ramp voltmeter or damp type DVM, whatever be the signal we given as a input, it attenuates. After that, it fed to input comparator. Input comparator, again it is another one is, for the input comparator, another input is from the ramp generator. The ramp voltage is set as another input. Sample and multi-vibrator produces ramp voltages. Multi-vibrator, that ramp generator, multi-vibrator and ground comparator it is. Here input comparator is also connected to gate, start and stop pulses, clock oscillator. Number of clock pulses will be produced by clock oscillator. After that, whatever be the signal we given, that is compared with the ramp voltage. The number of clock pulses counted by counter. The number of clock pulses will be counted by counter. After that, the number of clock pulses read out, that is the unknown voltage or measured voltage in case of DVM. You can see the what are the various parts of ramp type DVM. Input voltage is given to ranging attenuator, attenuates the value. After that, input comparator. After that, it is fed to gate. From here, okay, at the start of measurement, whenever the meter want to measure the voltage, a ramp voltage is initiated. A ramp generator generates the voltage. Ramp generator is initiated. A negative ramp is used. In the diagram, we can represent the diagram also. But a positive going ramp may be also used. At this time, counter is set to 0. At this time, counter is set to 0 value. And sample multi-vibrator gives a number of pulses which initiate the ramp generator. A sample multi-vibrator gives the signal to initiate the ramp generator. The ramp voltage is continuously compared with voltage being measured. Unknown voltage తో ramp voltage compare చేస్తుంది, number of pulses generate చేస్తుంది అన్నమాట ఇక్కడ. That is a ramp DVM actually. What is the function of input comparator is, at the instant of ramp voltage is equal to unknown voltage, that is coincident circuit is called input comparator. Suppose 10 volts అనుకోండి, 10 volts peak voltage తో input comparator కంపేర్ చేస్తుంది. అండ్ గ్రౌండ్ కంపరేటర్ గ్రౌండ్ 0 ఎప్పుడైతే వోల్టేజ్ అప్పుడు కంపేర్ చేస్తుంది, అప్పుడు స్టాప్ అవుతాయి పల్సెస్. నెంబర్ ఆఫ్ పల్సెస్ జనరేట్ చేస్తాయి కదా క్లాక్ ఆసిలేటర్. పల్సెస్ 10 volts నుంచి 0 volt వచ్చేంత వరకు పల్సెస్ స్టార్ట్ అవుతూనే ఉంటాయి. అంటే ర్యాంప్ వోల్టేజ్ జీరో రీచ్ అయ్యేంత వరకు ర్యాంప్ వోల్టేజ్ ఇలా వస్తూ ఉంటుంది. 10 volts నుంచి అజూమ్ దట్ పీక్ వాల్యూ టు 0 volt వచ్చేంత వరకు, 0 వచ్చేసిన తర్వాత స్టాప్ అయిపోతుంది. అప్పుడు పల్సెస్ కౌంట్ చేస్తుంది, నెంబర్ ఆఫ్ పల్సెస్. ఇక్కడ ఒక గేట్, ఇన్ దిస్ వన్ గేట్ ఈస్ దేర్. The time elapsed between opening and closing of the gate T indicated that during this time number of pulses will be passed to counter. 10 volts to 0 volts reach అయ్యేంత వరకు ramp voltage, number of pulses will be passed to counter and counter counts the value. The decimal number is indicated by readout, that value is unknown voltage. That is the actual thing is happening in digital voltmeter. Now see the waveform, or that is working. This is the timing diagram related to ramp type voltmeter. A negative ramp from 12 volts, positive plus 12 to 0 and minus 12, a negative ramp is started. You can see in this diagram, timing diagram, it is of ramp type of DVM. First, the negative voltage, negative going the ramp, that is positive, not it is the ramp voltage coming to 0. After that negative going ramp we are using. First ever, whatever be the unknown voltage. If the unknown voltage is, this is the unknown voltage. This is the unknown voltage, blue color. First the ramp, negative going ramp touch the unknown voltage here. At this coincidence 1, the negative going ramp touched. At that moment, the gate timing interval will start. Gating time interval. That means number of clock pulses will be started to counter. Number of clock pulses will be passed to counter. Gate will open. Upon number of pulses will pass until it touches to 0 value. When touches the negative going ramp to 0, the number of clock pulses will be passed to the counter. After that, counter counts the number of pulses. This pulses gives rise to the voltage of unknown. That is 12 volts is indicated by these pulses. 6 pulses or 12 pulses according to sampling. According to sampling rate, number of pulses will be counted. Okay, again I am explaining what is ramp type DVM. The ramp type DVM, first how it measures. First the negative going ramp will be started. Like this it moving continuously. Suppose if you give a voltage 2 meter, that voltage touches the or negative going ramp touches the unknown voltage. Unknown voltage may be whatever be the voltage, it is 10 volts or 20 volts or 50 volts or 1000 volts, whatever it is. Assume that 100 volts. Now the 100 volts touched this coincidence 1, it is known as coincidence 1. It is known as coincidence 2, 0 point. This is the unknown voltage, 0 voltage, and unknown voltage peak value it is. Unknown voltage peak value it is. This is the unknown voltage peak value, it is the 0 value. Between that, number of pulses will be generated in ramp type DVM. Okay. These pulses are counted by counter. That is given by readout. Readout means what is the value of unknown voltage. That is the readout. Actual thing happening in digital voltmeter ramp type. We can see the theory about this. Now we go for theory about ramp type DVM. We know that timing diagram, how the timing diagram works, how the ramp type DVM works. Similarly, the same theory we are explaining here. First, at the start of measurement, a ramp voltage is initiated. At the start of voltage, a ramp voltage is initiated. A negative going ramp, we are using a negative going ramp in the diagram previously. But a positive going ramp also we can use. Mostly we are using negative going ramp for any types of DVM, ramp type DVM. At this time, counter is set to be 0. The counter becomes 0. First, whenever the ramp voltage is generated, that is counter is 0. The meter shows 0 voltage. The meter shows 0 volts in digital display. A simple sample multi-vibrator gives a pulses which initiates the ramp generator. The ramp voltage continuously compared with voltage being measured, that is unknown voltage. What is the purpose of input comparator is at the instant of ramp voltage. When voltage is 100 volts, the peak point of voltage, the ramp voltage touches the peak point, then that is input comparator compares the peak value, that is input comparator coincidence. Also already I told you in the diagram, coincidence 1, input comparator compares the value of continuously with 0 voltage. Okay, input comparator peak value తో కంపేర్ చేస్తుంది అండ్ పల్సెస్ ఓపెన్ అవుతాయి, పల్సెస్ జనరేట్ చేస్తుంది పల్స్ జనరేటర్, దట్ ఈస్ క్లాక్ జనరేటర్. క్లాక్ ఆసిలేటర్ జనరేట్స్ నెంబర్ ఆఫ్ పల్సెస్. Now coming to ground comparator, the ramp voltage is continuously decrease till the ramp voltage reach to 0 voltage or ground level. At this time or instant, the another comparator called ground comparator. The ground comparator generates a pulse to stop the gate, close the gate. That means stop the gate means close the gate. At that portion, when ramp voltage reach to 0, then the ground comparator gives a signal, give a pulse to close the gate. When the gate is closed, what happened? The number of series pulses will not move to the counter. Or clock pulse generator or oscillator. What is the purpose of clock pulse generator or oscillator? It produces number of pulses. What is the function of clock pulse generator or oscillator? The time elapsed between opening and closing. Time elapsed between opening and closing of the gate is T. Already we told in timing diagram what is the T. Time elapsed figure 2, already we drawn a timing diagram. During this time, pulse from a clock pulse generator passes through gate and are counted by counter and displayed. The decimal number is indicated by the readout as the true value of unknown voltage. That is the principle of digital voltmeter ramp type. Okay. First, the negative going ramp is generated. After that, it goes downwards. That is negative going ramp. Negative going ramp is moving. You know that. When it will be moved downwards? At the start of measurement, when the negative going ramp started, when the ramp is going to started, of that moment counter or readout is 0. It shows 0 voltage. Means counter displays 0. That means negative going ramp is started. Now the negative going ramp meets the unknown voltage at coincidence 1 and coincidence 2, and that means the time elapsed between negative going ramp measure that touches the unknown voltage, coincidence 1 and coincidence 2. This is the coincidence 2. After that, the number of clock pulses will be passed. అంటే ఇక్కడ స్టార్ట్ అవుతూనే గేట్ పల్స్ ఓపెన్ కాదు, గేట్ when it touches the coincidence 1, when negative going ramp touches the peak value of unknown voltage, then the gate will open. మళ్ళీ గేట్ ఎప్పుడు క్లోజ్ అవుతుంది? జీరో వోల్టేజ్ టచ్ అయినప్పుడు. నెగిటివ్ గోయింగ్ ర్యాంప్ వెన్ టచెస్ టు జీరో వోల్టేజ్, at that position the gate will be closed. In between that period, number of clock pulses will be generated. These are the pulses which are generated. Okay, like that DVM ramp type works. What are the advantages of negative ramp type DVM? Let us see. What are the advantages of negative ramp type DVMs? The ramp technique circuit is easy to design and cost is also low. Most of the meters are ramp type DVMs, and output can be transmitted over long feeder lines also. We can transmit the data for longer distances because it's a digital form. Disadvantages are there. Ramp signals requires excellent characteristics. That is one of the disadvantages. The ramp signal, not only ramp signal has excellent characteristics, then only accuracy will be more. Large errors are possible when noiseless supervised and input signal. When the signal is noise is supervised, అంటే ఇన్పుట్ సిగ్నల్ ఎక్కడ నాయిస్ ఉంటే కానీ ఎర్రర్స్ ఎక్కువ వస్తాయి. ఇన్పుట్ ఫైల్స్ ఆర్ రిక్వైర్డ్ ఫర్ దిస్ టైప్ ఈస్, that is input filters are required for ramp type DVM. These are the some advantages and disadvantages of ramp type DVM with the timing diagram and circuit diagram. It is important for exam point of view. Thank you.